Uh, Hello, I'm Dimitrios Kechagias. Uh, I'll answer to any prefix starting with the letter D, including just the letter D. Okay. Um, I'm a principal developer at SpareRoom. It's a roommating finding service. It's kind of a household name in the UK. So I flew all the way from Manchester to be with you today and discuss about maximizing cost and efficiency in the cloud. Um, my interests usually are in algorithms and optimization. So I've given a few talks in past years about optimizing things. And in my last year, I did a real world performance optimization where I mentioned some tips about optimizing things in the cloud. And I thought since most companies or like even individuals nowadays run things on the cloud, I should just make a longer talk about it. So the cloud, it's just somebody else's computer. I'm not a cloud evangelist. Like I won't tell you to move your stuff to the cloud. But there are many reasons, many cases where you'd want to run something on the cloud because that somebody um, is usually an expert in data centers. So you get some advantages, like starting a project. You don't need any upfront investment or anything like that. No upgrade costs, uh, scalability, global reach. You can have servers near your customers. Um, many features. Anyway, and you will be paying dearly for most of these features. Um, so you need to figure out some strategies to minimize that. Um, I should briefly mention SpareRoom's cloud journey. So it's like it's been around for 20 or so years. That's why I guess everything is in Perl because it started at the peak of Perl, and it was using co-located servers in Manchester. Um, so about a decade ago, we expanded to the US. So an Amazon cloud solution was used mainly to have servers near the customers and to try out and see how the cloud would work for us and to start from scratch with no users and be able to grow. So 4 years ago, we transitioned uh, our UK service to the cloud. We chose GCP this time at the time because of cost issues, and so the initial running costs were quite substantial. I mean, we expected that, but uh, as an idea, the cost for 6 months of GCP was equal to the entire amount we have paid for the entire data center, like 2 racks of servers. Um, and the platform team back then did a like for like uh, thing moving to the cloud, but the performance was degraded, so we didn't get the same performance. But I mean, after like tweaking things and learning things and making many changes, so we did eventually manage to reduce costs by over 40% from that point, while increasing performance by about that much. So uh, it started being a good solution, and we gained at the same time like some new significant abilities. We can now, like if everybody's working, we have a CDCI system. When you the moment you commit something, it fires up our entire Perl suite, which is thousands of tests. And if many developers are committing at the same time, you can just spawn as many test suite servers as you want, and they they can run through the whole thing in like 40 seconds. So we didn't have such an ability before, or we can launch as many test environments as we want. There's no limit, and the cost is minimal using spot VMs, which we'll discuss later. And also, as new technologies come out, our performance keeps increasing for free, basically, because we just switch to new types that are available. So overall, it's working okay, and the lessons we learned are shared with you today, and some of them are, for example, that there's no like for like when moving to the cloud, because our racks had there were 32 core Haswells, for example, so we switched to 32 core Haswells, but we had the fastest, like the 3.5 gigahertz ones, while the cloud providers use the most power efficient for running costs. So they're not equivalent. There were assumptions about, Google Cloud is like super fast networking, but you cannot beat physics. So if you have two servers that are like 2 centimeters apart and you have like a little cable going from one to the other, the network lag is different than having like in the same building or something like that. I have an example of, so on the same rack, we had less than 0.1 millisecond of DB access network delay. I don't remember couldn't find the exact number, but it was under that. So now, if we're on, we have 2 servers on the same GCP zone. GCP is Google Cloud Compute. It's 0.1 to 0.4 milliseconds, which is already an increase. But we moved to a managed cloud SQL service, and it's 0.7 to 1.4 milliseconds, which you have to make up for somehow if you don't want to degrade the performance. That's caching and things like that. You need to, if you move to the cloud, you can't do the same thing you did in the data center. Otherwise, there's no point. You just pay more. So you should take advantage of the spot instances to like generate servers as you need to, and you need to use whatever the cloud provider gives you to lower costs, like reservations, an example which we'll talk about later. And another lesson is that you can't just let the cloud engineers design your solution. You have to get the developers involved, to people who know what the app exactly is, what it does, and they need to benchmark your solution and do a performance cost analysis. And because cloud pricing is not related to performance. Everything they sell you, it's how much it costs to them. It's not how fast it is or anything like that. And also remember, every little thing costs. Like you put a tick mark here, enable this API, immediate cost, or enable query reports. That's an additional cost. So you have to stay on top of your spending. I will go through the last 3 in reverse order in more detail. So you should have someone looking after costs. It doesn't have to be what they call now the FinOps person. It doesn't have to be a new position, but there needs to be someone who understands all the projects, and he can follow the billables and look for cost anomalies. So it will his job will be easier if you separate your projects in the way you organize them, the resources, and use tags and other things that the cloud providers give you to make it easy to attribute cost. Like if you see a cost increase, you should be able to immediately identify which environment it is, which project it is, and know where to look for what's going on. There are automated alerts you can set up. You don't have to like open the browser every day yourself. Um, and I recommend every now like quarter do a cost audit to see what changed and or what can change. I'm bringing up an example case from SpareRoom that I noticed a while after we had started our GCP journey. I couldn't account for about $150 per month worth of cloud DNS and cloud logging. I wouldn't be able to see that in the production environment, but it came up in the primary UAT environment, which shouldn't have these. So I could look at specifically what was going on there. And it turns out it was a process that does continuous background checks. It calls like opens accounts all continuously, and it was not passing the database handle. So for every call, it was just using the host name of the cloud SQL server to open a connection, and that's actually expensive if you're on a cloud provider because you're using their cloud DNS. And it also adds, if you have logging enabled, it also adds a long log entry. So you do that in a loop 24/7. It's a cost. So yeah, it can't happen to our main app because we count connections. So it would have shown up. But it was like a weird background process that nobody remembered. I talked about benchmarking. So there's quite a need for benchmarking, I think, because, as I said, the price of the various shapes they provide, they're not proportional to performance if it's different types of shapes. They charge you more for running older types of CPUs because they use more power for the same performance. So there's no reason to use them. But sometimes they might have them in abundance. So they reduce the price. So anyway, you have to benchmark, and they give you all the big providers. They give you big discounts if you commit for 1 or 3 year usage. They give you a bigger discount if you can commit for a specific type of resource of a VM. So if you're committing for 3 years to get the maximum, you really should know what the various types give you in relation to each other, because it makes a big difference down the line. And then you might see some types that you don't really they don't really seem interesting, but then they come up with a very low spot instance price. So it's better to know how your solution performs on everything, to pick whatever comes up as the best at the time. So I have on CPAN, I have a solution I work, a test suite I use. Originally, I just had it with our own code. So then I replaced it with various modules that we use or other people use. So I published something that is like a turnkey thing. You can just download it and run dkbench, and it will download like lots of CPAN modules, Perl or CL or XS, and we'll run single-threaded, multi-threaded under the many core engine, which is usually my preferred way of running things in parallel. And it will print out your scores and your the scaling of your system. But you can also run your own code under the same framework. This is an example of giving it a reference to your code and having it run only that instead of that along with the rest of the suite. This is the example output of the default run. on my Mac, it runs the 19 benchmarks, or 20, yeah. If you have installed BioPerl, it runs BioPerl 2, so 20 benchmarks, single-threaded, multi-threaded, and the scaling. It gives you nice convenient scores, or you can just have it show time. You don't like scores. So since I did it for every type of GCP option we had, because I needed it to decide what we should be running on, I published the results and I included other cloud providers as well. And since then, I try to do it every year, so that you don't have to run it unless your code is very special. So you'd like to run your own code, because your own code is always the best benchmark. Anyway, this is from the example extract from the last year's publication. I haven't finished the graphs for the 2024 edition, which should come in a week or two. So there are sometimes you go for the best value, sometimes you go for the best performance. And I should note that there are some additional benefits of getting faster CPUs. Usually they are actually cheaper, and they just make your application faster. But also, if you don't need more speed, you might get to reduce the number of nodes you need, which then reduces the loading, the networking, which are all things that you pay for in the cloud. And they're especially relevant in licensed per core software. Like if you're in the Microsoft stack, we had a big Microsoft SQL server from we bought a competitor who was on Windows, and it was a 12-core Haswell, an aging thing, and we replaced it with a new Azure instance using their fastest available CPUs. It was an Ice Lake where 4 new cores were faster than 12 of the old ones, and because you license by core, the price dropped to less than 1/5. So I mentioned the spot instances. They are all the spare resources that the providers have. They give it at a discount, but the idea is that when a client picks up this resource as a regular on-demand resource, they can preempt your spot instance. They can just kill it and have to spawn off a new one. But it is one way to beat your having your own co-located server in price. So you can't use it for everything. It's especially good for if you need something stateless or fault tolerant. They can be used in auto-scaling groups. So you can, especially on Amazon, if I remember correctly, you can combine regular instances with spot instances in auto-scaling groups. You can have 2 base instances, and then when you have traffic, it can start increasing the number using spot instances and replace them live. The pricing of spot instances varies widely with region because it's a different data center, so they have a different allocation of things. And with time, like every month or so, you might see quite some differences in price. They can be used in many things because of they don't just die, they give you a warning. So you can get a 2-minute warning on Amazon or Oracle, or a 30-second warning on Google and Microsoft, which should be enough to gracefully shut down, for example, a web server or something like that, and get it replaced with a new one. So here's an example. I'm using something that we'll see is one of the best values in the GCP cloud is it's a 32 core AMD EPYC Milan instance. So it goes down from $987 a month to $140 a month as a spot instance. So I will compare it with buying a system. The cheapest I could find was a Supermicro 1U unit. So you can buy it for $4,500. And this is the cost of ownership over 3 years. An inexpensive colocation for that system would be about $200 a month. I don't think I could find anything cheaper that's reputable. So you can see the red line. If you pay on demand, which is the price you pay without any reservations on GCP, in like 6 months you have paid the entire cost of the system plus whatever colocation costs. If you reserve for 1 year or 3 years, you can get quite a good value. As I said, this particular instance is one of the good values for GCP. But the blue line is your colocation costs. But the spot price, it's like in 3 years you'll have paid just the cost of buying the machine in the first place. It's not the same. It's a spot instance, so you have to, like, it can't replace everything, but with smart usage, it's a good value. I'll go into some compute basics because I will mention some things later. So they sell you vCPUs. Sorry. There you go. So they sell you resources by vCPUs. A vCPU can have 3 different meanings. What was that? Okay. On hyper-threading or symmetric multi-threading systems, which is most Intel or AMD systems, they give you 2 vCPUs per core. So they are, as Intel calls them, hyper-threads. In reality, so 2 vCPUs in that case is actually not like twice the power of 1 vCPU. One way to think about it is that you're really getting about 1.15 to 1.2 times the vCPU for every 2 that they sell you, or a bit higher if it's an AMD system. This is in contrast to the non-hyper-threading systems, which is all ARM systems, or some x86 solutions that have hyper-threading disabled. So that's namely the T2D type on GCP and the C7A on AWS. So they give you 1 vCPU per full core. So 2 vCPUs are twice the power of 1 vCPU. It's very simple. And lastly, there's the shared vCPUs. So those are completely virtual CPUs, and so they have a hypervisor on a system that has let's say 32 cores, and they subscribe people who buy like 300 vCPUs on this system. So if only 32 vCPUs are active at this time, you get the full power per vCPU. Otherwise, it starts time slicing, so you share these resources. And the 3 large providers, they sell them as burstable. So you get credits when your usage is low, which you use them to use maximum CPU usage when you need to burst. And that's one way to have predictable performance. But they're overall the cheapest, usually the shared ones. And the small providers, they don't do the burstable thing. They just give you the portion of the available processing power. And if you buy two vCPUs that are shared, they behave like the regular non-hyperthreading system. It's twice the power of one vCPU. So quite often they're quite a good deal because if you find a reputable provider, they don't oversubscribe. And we'll talk about that later. Now, the different CPUs vary in performance mainly by the generation. So this is a nice chart I made it last year, and I updated it with the new things available this year. So Epic Geno was just coming out last year, and this year we also have Emerald Rapids from Intel. It's good to look at when you're comparing things to get an idea without having to run any benchmarks. But of course, it doesn't tell you anything about the clock rates that can make performance vary a lot, or the hyper-threading status and things like that. And I should say here that I've read online that if you have bare metal servers, which is without a hypervisor, you gain like a 30% of performance. And there are some providers that give you that option. For example, Amazon has is providing it for some servers, but at least with modern systems, I don't see much of a difference. Well, a much smaller difference. Like the shaded one, the one with stripes, is the bare metal version. On the left, it's single thread. Right is multi-thread performance. So you can see the red one, the AMD. There's like less than 10% difference on multi-thread, and I mean, there is a regression actually on the Intel one, multi-thread, but I think that's like the error that you can get. So yeah, I'd say that you shouldn't like be trying to go bare metal for the performance. Usually virtualized is easier to work with. And if you're running containers, in general, they should not affect performance. If you're running Kubernetes, it's or something of whatever flavor of it, you do have some overhead for managing the nodes and RAM and CPU. It may be significant for some workloads, it all depends. But even those, they run on VMs, so everything I say about VMs applies. So I'll take a quick look on some specific tips about specific providers. And I start with Amazon Web Services. So in general, if you want to get the best value on Amazon, you either go with their own Graviton 3, which is an ARM solution, or their new Epic Genoa AMD solutions, like the C7A. And the C7A is also 40% faster than the Graviton 3. So if you want the maximum performance per thread, you get that. But you pay the same because it's 40% more expensive too. So the 1 year or 3 year reservations make a big difference in price. If you don't want to commit, there is a way to get the 1 year reservation price without reserving at all, just on demand. That's by signing to a third party and buying the service through them. We use it to Do It International's FlexSave. So they have a big account with all the providers, and when we buy Amazon cloud resources under them, they have like lots of 3 year reservations that they allocate to their customers. So they charge us the 1 year price. They get the difference because they get the 3 year discount, but we don't pay anything to anyone. So we just get a discount for nothing. And they also give us customer support in addition to the cloud providers. if you have like significant cloud assets, it's worth looking into them. So prices vary per region. That's true for all the providers. So you don't really need a specific region to shop around. And spot instances vary even more per region. So there's more research going on there. But in general, their spot discounts are less impressive than Microsoft or Google. And Google Cloud gives you, in general, the most customization and variety for VMs. Like you can select, in the others, you cannot select whatever RAM for vCPUs you need. So I like them for that. An interesting trick is that they have some types where by default they can come with a different generation of CPU. But if you don't specify a CPU type, they give you the slowest one. So by adding just one variable in your call, you get for free a lot more performance. In the M2D VMs, you get 30% faster CPU if you define AMD Milan. Otherwise, they would give you AMD Rome. Same with the N2. Same with the N1. We specify Skylake. Otherwise, they give you Broadwell or Haswell. There's no catch. You just change your one line of Terraform or GCP console or whatever you use. Then to these I mentioned are the best value for on-demand prices. In general, AMD solutions are a bit better priced currently than Intel solutions. The max per thread performance right now is the C3D on Genoa. They do have C4, which is Emerald Rapids in preview, and it's fast, but we can't talk about that. In general, you don't want to be paying on-demand prices because, as we saw, they're expensive. So if you start doing reserved instances, the T2D is the Tau instances, as we call them. They offer a great deal because they give them to you for the same price as the N2D, and they're just the same physical CPUs, but you get twice of them for the same money because they don't have hyperthreading, but they still sell you per vCPU the same price. So if you reserve, there's no reason to get N2D or anything else, pretty much. Except the newer C3Ds, those are the best right now for single-threaded loads because they're so fast. And they can approach the TPD in multi-threaded value. So yeah, and again, spot instances, they vary widely, so shop around. We're not an we're not a Microsoft company, but we have bought a couple of competitors who use Azure, so we do use it a little bit. And in general, if you run in Windows workloads, you can rarely go better than Azure because they give themselves a big discount in licensing. So if you we were comparing the pricing if we went to Google versus Microsoft, and the hardware was much cheaper at Google, but then the licensing was all the price you paid. So the cheaper licensing made it a no-brainer to go to Microsoft. And for Linux, their ARM VMs are the best value for multi-threaded loads. You don't care about, if you care about small, single-threaded things, just make sure you stick to the latest generation. If they charge you the same for old, or even more expensive for old generations. So you have to always choose the latest one, which is the cheapest, so the best value. They do have some spectacular discounts for spot instances, down to 90%. Quite often they're more impressive than Google for spot instances. So Oracle Cloud, surprisingly, is an amazing value. and they have a great free tier. I know what you're gonna say. Yes, it is a trap. Of course, it's a trap. Um, they're in the hostage taking business, so they'll try to lure you in and get you to use their like overpriced things with a lock-in. But hear me out. Hear me out. So they they give you a free tier. It's something free resources forever. It's like a credit, which ends up being something of these specs. It's a 4-core Altair Ultra. It's an ARM CPU with 24 gigabytes of RAM, 200 gigabyte disk, and that's over $120 a month on GCP. So they give you that for free. Plus another 2 small instances of AMD that are not worth mentioning. So this is, you can start a free account and just stay, like, don't get charged for anything with just that. Or if you pay for an upgraded account, you can like add more things, but you're not paying for those first 4 vCPUs. Couple of tips: make sure you don't sign up while you're under a VPN. They will like block your account, and don't include Oracle in your email. Like, I give a different username to each company, so I know who sold my data. So, like in Gmail, you can do plus company name or something. And apparently, if in their systems, if your username contains Oracle, it assumes that you are under the Oracle organization somehow. So my account ended up being not upgradable because I was not Oracle. So I could not, I needed like an enterprise. Anyway, it took 2 weeks going back and forth with the support to sort it. But at least they have support that responds, even though, it got confused for a while. So even beyond this free tier, on full cost, the A1, this ARM type, is a better value than anything else that the big 3 providers can offer. So even if you buy like 3-year reservations on GCP, you still cannot beat the price of this. So it's ideal for small projects. I mean, you still have to make sure you don't start using any overpriced Oracle things. It's like since we're in Vegas, I remember the first time I came in Vegas, I was a student, so I had more free time, and there was these people giving leaflets about going to timeshare meetings. So they offered you like free breakfast and a show, tickets to any show you wanted. So I just went there, had a free breakfast. I quickly declined their timeshare offer, and I got my show tickets. So, I mean, let this be your Mamma Mia tickets, right? So don't sign up for the timeshare. Spot instances are a 50% discount in cloud, which is quite interesting. Let's go to some smaller providers, which are also good for small projects. And I've used Linode, who are now bought by Akamai for 15 years now. They were very good always. For a while, they started being quite slow, but they upgraded their fleet to Rome and lately Milan. So basically, when you buy on demand, you pay by the hour on them. It's similar cost to going to GCP and buying a 1-year reservation, like that sort of performance to cost you expect. And just make sure they do still have some old Naples servers, which are like half the speed for the same price. And just if you build a node, just make sure the model number doesn't end in 1, it should be 2 or 3. Otherwise, they're a good provider, and like they have easy backups and things like that, and they're quite reputable. if you want to go to an extreme budget provider, I haven't used Hetzner, but people I know have, and they swear by them. So they're shared CPU solutions. Oh, sorry. For Linode, make sure you buy the shared CPU version, because the dedicated is a waste of money. They're not oversubscribed, so you're getting basically the same thing for more money. Plus, because it's hyper-threading, you're ending up with perhaps fewer total multi-threaded performance rather than having the shared CPU. So Hetzner, the CPU, shared CPU are much cheaper than anything else. I tested them and they didn't seem, I tried like a few days in a row and they didn't seem oversubscribed. So I don't know how they make their money. Yeah, you can try them out yourself if you're interested. Yeah, if you're afraid of Oracle or small things. I'll go on to a bit of disk and networking performance, still in relation to VMs. So usually, if you read the details, most providers, the big three certainly, they limit the network bandwidth, just the egress, usually, depending on the number of vCPUs of an instance. So make sure you have you don't have too small instances if you expect a high throughput. And the number of vCPUs and the disk size affects the throughput and max IOPS of attached storage. So like sometimes we have to buy a bigger disk just to have it be faster, which is not like obvious. Yeah, and remember, like if you have managed services, they still run on VMs, so you need to allocate more vCPUs to your cloud SQL instance if you wanted to have faster networking. Yeah, it make sense to have fewer nodes but bigger ones so that they're more performant in that respect. We use a lot of object storage because it's cheaper and more convenient for many uses than other types of storage. So we use S3 on Amazon, but Google has a similar thing, and I'm sure Azure has something as well. Actually, yeah, we use some Google storage too. So by default, it's you get the standard storage tier, but you usually pay more because that's supposed to be only for frequently accessed like hot data. And if your data becomes stale, you can start moving it to cheap cold line or archival storage tiers. This does require something on your part, like some development part. Although S3 does offer specifically an intelligent tiering, so without you doing anything, it moves it to the correct tier depending on how often you access it. But it charges you per object. So if you have like image files that are reasonably small, it's not cost effective. But if you have large files like video files, it's quite good. There are, besides the archival and the hot data, there are intermediate tiers which are more interesting. Sometimes you can just switch between them without doing anything else, just a configuration change somewhere. For example, most of our ads historically are offline, right? People create ads, they rent their place, and then they deactivate the ad. But the images stay in our storage until GDPR rules theoretically, because they can reactivate the advert at any time they want unless they choose to delete their account. So most of our images are not used, and we could theoretically move them to a cold line storage, but that would require some work from us, and we're doing other more interesting things. So we calculated that if we switched to another type of storage that is compatible to standard, it's called standard infrequent access, which is just an API call to change the entire storage to that. It saves us $900 a month for the UK service because of the ratio of the accessed versus the non-accessed photos. And I think that was all I thought we'd include. Anything, Sally? Yeah? Okay. Yeah, sorry, I came one day later, so I didn't run through to see the time, so I made sure I had less than more. So thanks. Let's you can get the slides on this link because that did have some information that I went on through very fast, and there are links to the the performance comparisons. The 2024 will come in a couple of weeks, and I can take questions now. Thank you. Yes. No, I have tried Tencent, OVH, IBM. Well, that was fun. Yeah, IBM. Yeah. Alibaba. Anything else? DigitalOcean. DigitalOcean was quite good, but they're oversubscribed right now, so don't recommend them. Yes, you guys see. Mm-hmm. So Google changes them once a month, but they don't jump that fast. Amazon changes them a bit more rapidly, but it's still easy to find. And Microsoft has a very weird thing of finding them out, but they change at random intervals. Again, not big jumps though. They offer APIs. They offer APIs so you can set up your. What we do, because prices don't change that fast, I just stay on top of them and reevaluate every like 6 months or so. So that's enough usually to get the best value. No. Every 6 months is a good. Usually, when they launch a new type, that has in a few months it makes a few differences, something like that. Any other questions? No. Thank you very much.